Hi, welcome back. So we're in chapter 3, You Must Know, and we are at the outline of equation and function and system. I think this outline one of the most important and fundamental perspective that you have really to understand in order to master the use of mathematics as an independent language. And the fundamental seed of this outline start with the word equation. And as the name is indicating, equation means the equality between two sides. And if we come to understand the meaning of equation, then we're going to upgrade that to the concept of function and then concept of system. So let's go ahead and visualize the meaning of equation. Imagine I would have two sides, like a left-hand side and a right-hand side, and between them the equal sign. That means whatever is happening on the right-hand side should be equal whatever happening on the left-hand side. And both of them, or this entire expression, let me say, from polynomial perspective, it is within a certain or a bigger domain, something like that. Now, from this picture, what you could start to visualize that this big domain, I'm going to call this circle as a domain on its own. It could be in any number system. A number system may be real, maybe integer, maybe complex. It doesn't really matter. For example, if I would have to say this is a 3, it should be exactly equal on the right-hand side, again a value of a 3. But also I can express in a different way. Both of them are polynomial constant, but I know that the sum of this is just equal to the value of 3 as well. Also take this one step further by importing the idea of polynomial, that the alpha, it is a quantity of y. An x indeterminate, it could be any number. Let's say if I would have y to be equal to 4. Let's assume that I want x to be a value of 2, as an indeterminate could be any number, right? What is the value of alpha based on the indeterminate value of x that have been decided? In this case, this will lead me to the value of 4. I can actually express y in terms of as many of alpha 1, x. One important thing is that we know in the number system the value of null. If would have been x actually every variable here to have the value of null of 0, then that means that this entire value of this term should be equal to 0. We need here to add a term that is representative as a constant for the value of y. In this case, we're going to call it alpha 0. Now, this is numerical representation on the idea of equation. From a visual perspective, using a geometrical presentation, in this case, we're going to stick to a 2 dimensions. So we're saying that alpha 1, x1, this line here, okay, represent the line of x, and this line here represent the line of y. Both system together, if y moved by 1 unit, I mean here, what was happening to the x? So what happens here when we say 1 and 1, we are saying this is 1 unit of x and this is 1 unit of y, so I am at this point here. So you could see the pattern here, connect all these points together, representing the relationship between the x and the y. Alpha, as we said, it represents actually how much y was changing when x was changing. Let's just start at this exact second point here. Let's see how the change happened. Now, to find out the change, we need to go one step back. So, in other words, what was the previous value of y minus the y current, which is now, and divide by the previous value of x minus the current value of x, something like that. You could see this is what we call rise over run, in other words. And this is what we call a linear behavior of this system. As I have mentioned earlier here, if this term x happens to be 0, in this case, what we assume, as we said, that y will also be 0. If I would assume a new alpha 0 here, this is what we call actually the intercept of this equation. Why intercept? Because it intercepts with the exact value of y. And from here, of course, the line will go on as we have just drawn. Whatever the value of y gonna be taken, it is determined by the value of the domain of x. So the values of x, the indeterminate here, we call it the domain, codomain of it, which is we call it in this case I. Now let's try actually to find out a real example by transforming a real world problem into some sort of equation. One product of this is just equal to 5. Now this is going to be my milestone. The statement of the problem, if someone buys 5 items of this product, how much money he has to pay. Now, if we want to translate this into a mathematical language, this is a word language. I'm going to say the product, for example, represent, let's say X, and the price represent Y. I want to say Y is equal how much? This value of X, 5. And this alpha represent for us how much the change of Y happened when X was changing as well. And according to the given fact or the milestone in here, when X was changing 1, Y was changing 5. When X was changing by 1, Y was changing by 5, multiplied by the indeterminate variable, we said 5 items of X. If I want to generalize the solution, this as a function of f of X, this is the meaning of function, equal 5, which represent this, multiplied by any chosen value of X. Now, if I want to also visualize this, I'm going to get some sort of a line looks like this at the end. Items are represented here by X here. So I could come into 5 here and I go up to the line. It should be at 25. Next, we will actually build up on this idea. I will see you then.